Hi all, good morning. Last class we were discuss about JK flip flop. Uh, we have discussed about the characteristics table of JK flip flop, truth table, characteristics equation, excitation table, a logical symbol. Everything we have discussed from the last class. Okay, here in the case of a JK flip flop, we have seen that if j is equal to 1 and k is equal to 1, if j is equal to 1 and k is equal to 1, then it goes to a toggle state. That means if the current state is 1, then it goes to 0. And if the current state is 0, it goes to 1. Okay. That means if the current state, that is if the both the inputs are 1, okay, if both the inputs are 1, then it goes to a toggle state. Okay, it goes to a toggle state. That is, the current input is 0, then it goes to 1, and if the current input is 1, current state is 1, then it goes to 0. Okay, so that was the situation. But in some situations, the clock pulse may too long than the propagation delay of the circuit. Okay, in some situation, it may occur. Okay, that means the clock pulse may too long than the propagation delay of the circuit. In that case, suppose consider if it is a level triggered flip flop. Okay, in that case, in a single clock pulse itself, it will be in a toggle state. Okay, in a single clock pulse itself, it will be in a toggle state. And that situation we will call a race condition. Race condition. We can see what is a race condition. Okay. That means the main idea behind this race condition means in a single clock pulse, consider if it is a level triggered flip flop, in that level triggered flip flop, in a single clock pulse, it will be in a toggle state. Okay, we can see how it will occur. Okay, consider this clock pulse. Okay, so this is a first clock pulse from here to here. Okay, and this is the second clock pulse. Okay, this is the second clock pulse. Suppose the propagation delay of the circuit, say it is delta t. Okay, this one. Okay, it is less than the TP. TP means the duration of the pulse. Okay, we are considering, suppose the delta t means the propagation delay of the clock pulse is less than the duration of the pulse. Then very less than means very much less than this much amount. Okay, then when you give the input, then flip flop will generate the output. That we know that. Okay, when you give the input, flip flop will generate the output. Initially, assume the Q is 0. Okay, initially you just assume that the Q is 0. Okay, so during the first clock pulse, what it will do? Okay, it toggle itself. That means if it is 0, then it goes to 1. Okay. Then after a delta t, this, okay, it again goes down. It again goes down. Okay. Then after a delta t, it again goes up. Okay. It again goes up like this. It again goes up. And after a delta t, it again goes down. Okay. Like that, it toggle in the clock when the clock logic is 1. Okay. Then when the logic is 0, it again goes to the previous state. Okay. Then again if the clock logic is 1, again it goes to toggle. Okay. That means if the clock pulse is too long, okay, too long, then state of the flip-flop means this one. Okay. Keep on toggling. Okay, keep on toggling. That means if the propagation delay is less than the duration of the clock pulse, and if the clock pulse is too long, okay, if the clock pulse is too long, then the state of the flip-flop will keep on toggling. Here you can see, okay, for the first propagation delay, it will toggle. Next one, it will toggle. Next, it will toggle. Okay, so in the next it will be keep on current situation, and again in the level triggered flip-flop, it starts to. Okay, so which will lead to an uncertainty in determining the output state of the flip-flop. Okay, so this problem is called the race around the condition problem. Okay, this is what the race around condition problem. That means if the clock is too long, okay, then the state of the flip-flop. Okay, if the clock is too long, then the state of the flip-flop. Okay, then what it will happen? The state of the flip-flop if the clock is too long, then the propagation delay. Okay, then what it will happen? The state of the flip-flop keep on toggling. Okay, the state of the flip-flop keep on toggling. Okay, so which will leads to an uncertainty in determining the output state of the flip-flop. Okay, so this problem we will call it as a race around the condition. Okay, so that is race around the condition in JK flip-flop. Okay, so this is the thing. Okay, race around the condition. That is JK flip-flop when J is equal to 1 and K is equal to 1. And is applied to the JK flip-flop, and JK flip-flop is level triggered, as we have assumed that if the JK flip-flop is level triggered, then output of JK flip-flop toggles so many times during the pulse width of the clock. Okay, output of the JK flip-flop may toggle so many times during the pulse width of the clock, and output of the flip-flop settled either 1 or 0 depending upon the pulse width of the clock and the propagation delay of the flip-flop. This situation we will call it as a race around condition. Okay, so this situation we will call the race around condition in JK flip-flop. Okay, so how we will eliminate this one? One solution is that to eliminate the condition, we need to keep the propagation delay is less than the clock period. No, the duration of the clock pulse is less than the propagation delay, but it is not possible. Okay, practically it is not possible to keep the duration of the clock pulse is less than the propagation delay. So, in order to avoid that situation, In order to avoid the race around condition in JK flip-flop, we will use another technique called master-slave flip-flop. Okay, we will use, that is a technique used to avoid the race around condition. Okay, we will use master-slave flip-flop. Okay. So that master-slave flip-flop we can study in the next class. Okay, but in JK flip-flop we had to understand that there is a problem associated with JK flip-flop. What is the problem in JK flip-flop? If J and K both are equal to 1, and suppose we are assuming that this is a level triggered flip-flop, okay, then the output of JK flip-flop toggles many times. Okay, it will keep on toggling, okay, during the pulse width of the clock. Okay, output will be an undetermined state. We cannot predict the exact state at that time. Okay, because it will keep on toggling during that pulse width. Okay, so that is the race around the condition. Okay, that is a race around the condition. So in order to avoid this situation, what we have to use? We will use another flip-flop that is called master slave flip-flop. Okay, we will use master slave flip-flop to avoid the race around the condition in the JK flip-flop. Okay, to avoid the race around condition in JK flip-flop, we will use master slave flip-flop. Okay, we will use master slave flip-flop to avoid the race around condition. Okay, so that is one, the race around condition. Then our next topic is T flip-flop. Okay, T flip-flop. This is the circuit diagram of T flip-flop. You can see here. We can obtain the T flip-flop from JK flip-flop. Okay, how when both the inputs are connected together, then that is a T flip-flop. Okay, in JK flip-flop, if you connect both the input together, okay, then that is a T flip-flop. Okay, JK flip-flop can be transferred into T flip-flop. T means toggle. Okay, T stands for toggle. Okay, how we will transfer the JK flip-flop into T flip-flop? T flip-flop means T flip-flop can be T flip-flop obtained from JK flip-flop when both the inputs are connected together. We have already studied what is JK flip-flop and all. Okay, if you connect the inputs of JK flip-flop together, okay, if you connect both the inputs of JK flip-flop together, then it will be a T flip-flop. Okay, and when the T flip-flop is activated, its output change its state at every time a pulse is applied to the T flip-flop. Okay, so this is the diagrammatic representation. We all know that it is similar to JK flip-flop, but the only difference is that we have connected the same input to both the NAND gates. Okay, we have connected the same input to both the NAND gate, 1 and 2. Okay, that means it have only one input. So we can call it as a single input flip-flop. It is also a single input because only one input. Okay, and it will generate two output. One is Q and the next one is Q1. Okay, remaining all are similar to JK flip-flop. Okay, because here it will be feedback to here. Okay, this will be feedback to here. Everything is similar. We are applying the clock pulse, and this is the our SR latch. Okay, everything is similar to JK flip-flop. Only difference is that we are connecting both the inputs together in the JK flip-flop. Okay, so that is the only difference as we compared with the JK flip-flop. Okay, T means toggle. Okay, next we can find the characteristic equation, characteristic table, excitation table, and the truth table of this JK flip-flop. Sorry, T flip-flop. So this is the circuit diagram of our T flip-flop. First, we can find the characteristics table of this T flip-flop. Okay, how we will find the characteristics table? We need to provide the input, and we have to assume that first we have to assume the current state is 0. Then next we have to assume that current state is 1. So in that situation, we need to find what will be the next state. Okay. So first, here I am giving an input 0. Okay. And assuming that the current state is also 0. Okay, current state is also 0. So we need to find the next state. Okay, how we will find? We are giving input as 0. Okay, and the clock is 1 here. Okay, then we are assuming that the current state is 0. That means here it will be 1. Okay, so what will be the output of first NAND gate? Anybody? What will be the output of first NAND gate? Here it is 0. We are giving this 0 to both the NAND gate. So here also it will be 0. Okay. Then what will be the output of the first NAND gate? Anybody? Anybody? Okay, correct. Correct. It will be 1. Okay. It will because നമ്മൾ already പഠിച്ചിട്ടുണ്ട്. Any of the input is 0, then it will be 1. Okay. Here also it is 0, so it will be 1. Next, we need to find the next output. That means we need to find Q and Q1. Okay, here we are assuming that Q is 0, so that will be feedback here. Okay, so here it is 0 and it is 1. So 1, 0, automatically the output will be 1. Okay, automatically the output will be 1. That will be feedback to here. And here it is 1, 1. If both the inputs are 1 in an AND gate, the output will be 0 itself. Okay, output will be 0 itself. So the Qn plus 1 is what? 0. Okay, the next state is 0. Okay, then next the same input to 0 is applying, but I am assuming that the next state is 1. Sorry, current state is 1. Okay, just I am assuming that the current state is 1. Then we need to find what is the Qn plus 1. Okay, here in here the same input I am applying 0. Okay, but I am assuming that the current state Qn is 1. Okay, current state Qn is 1. Then what will be the output? Here it is 1. This is also 1. That from the previous input we can find both are 1 because T here it is 0 itself. So if you are giving any one of the input is 0 in an AND gate, it will be 1. Okay. So here it is 1. Here also it is 1. So both the inputs are 1. Okay. So what will be the output if both the inputs are 1? Output will be 0. Okay, output will be 0. That 0 will be feedback here. Here it is 1 and it is 0. So we have studied that if any one of the input is 0 for an AND gate, the output will be 1. Okay. So the next state Qn plus 1 is 1. Okay. Next state Qn plus 1 is 1. So, okay. എന്താണ്
Qn plus 1 Qn bar 1
Qn bar is a complement of Q. Qയുടെ കോംപ്ലിമെന്റ് ആണ് ക്യൂ ബാർ എന്ന് പറയുന്നത്. Qn plus 1 എന്ന് പറഞ്ഞാൽ നെക്സ്റ്റ് സ്റ്റേറ്റിൽ വരുന്നതാണ്. കറണ്ട് സ്റ്റേറ്റ് അസ്യൂം ചെയ്തിട്ട് നമ്മൾ അടുത്ത സ്റ്റേറ്റ് ആണ് Qn plus 1 എന്ന് പറയുന്നത്. ഓക്കെ. നെക്സ്റ്റ് അടുത്ത എന്താ നമ്മൾ ചെയ്യേണ്ടത്? 0 ഇൻപുട്ട് കൊടുത്തു അല്ലേ? നെക്സ്റ്റ് we can give input 1. Okay, 1. So here it is 1. So ഇവിടെയും 1 തന്നെ. Okay, here also it is 1. Okay, then assume the present state is 0. Okay, so Q bar will be 1 ആയിരിക്കും അല്ലേ? പ്രസന്റ് സ്റ്റേറ്റ് 0 ആയിട്ട് അസ്യൂം ചെയ്തു. Here it is 1 itself. So we need to find the output of first NAND gate. Okay, so what will be the output of first NAND gate? Here clock is 1, our T input is 1, then one more input is here, so that is from here also Q bar is also 1, so all the inputs are 1 here. Okay, if all the inputs are 1, then what will be the output? If all the inputs are 1, what will be the output? Okay, correct. So output is 0. Output is 0. Okay, here T input is 1, clock is also 1, but this one is 0. Okay, because we are feedbacking the Q. Okay, it is 0. So here our input is 0 ആണ്. So the output will be 1. Okay, next we need to find the next state Q and Q bar. Here നമുക്ക് എളുപ്പത്തിൽ find ചെയ്യാം because here it is 0. One of the input is 0. That means output will be automatically it is 1. Okay, output will be 1 itself. Okay, then that will be here it is a complement. Okay, so it is 1. That means if you give T as 1 and the current state is 0, then you will get the next state 1. Okay, next T is 1 and assume that Qn is equal to 1. Qn is also is equal to 1. We can find the next state. Okay, so T is 1 and assume that Qn is equal to 1. Okay, Qn is equal to 1. Qn is equal to 1 and Q bar or it will be 0 itself. Okay, so we need to find first we need to find the output of the first NAND gate. So what will be the output of the first NAND gate? Here it is 1, it is 1. So one feedback will come. Here that was 0, so it is 0. Okay, if any one of the input is 0, the output will be 1. Okay, here 1, 1 and this is also 1. Okay, all the inputs are 1, output is 0. Okay, if any one of the input is 0, then you can directly write the output. Here it is 1. Okay, here both the inputs are 1. Okay, in this NAND gate, both inputs are 1. So output will be equal to 0. That means the next state is equal to 0. Okay, so this is the characteristic. Okay, in this characteristic table, you can find that if the input is 0, okay, if the input is 0, then output, that means the next state is same as that of the previous state. Here, if in the current state is 0, the next state is also 0. Here, current state is 1, next state is also 1. That means if you give the input as 0, it will keep on the current state. That means current state is same as that of the next state. Okay, but in case of that, if you provide the input as 1, 1 ആണ് input കൊടുത്തു കഴിഞ്ഞാൽ what will be happen? If current state is 0, then next state is 1. If the current state is 1, then next state is 0. Okay, so it will toggle. Okay, so this is the characteristics table. From this characteristics table, you can find the truth table. Truth table. So first input we are giving 0. Okay, 0. What will be the output? If you are giving 0 as the input, okay, Qn plus 1 is same as that of Qn. Okay, so you can write here it is Qn. Okay, Qn plus 1 is same as that of Qn. Okay, and if you give that is t is equal to 1, this situation. If t is equal to 1, what is Qn plus 1? That means if the Qn is equal to 0, then Qn plus 1 is equal to 1. If Qn is equal to 1, then Qn plus 1 is equal to 0. That means it is the complement of Qn. Okay, Qn plus 1 is the complement of Qn. 0 ആണെങ്കിൽ 1, 1 ആണെങ്കിൽ 0. So we can see that Qn plus 1 is the complement of Qn. So you can represent this as Qn bar. Okay, you can write this Qn bar. Next we can find the characteristics equation. So for finding the characteristics equation, you can use this K-map. Okay, so this is the K-map. We are finding the characteristics equation for Qn plus 1. Okay, so Qn plus 1. So from this characteristics table, you can find the characteristics equation. Okay. How we will find the characteristics equation? 0, 0, when these are 1. Okay, ഇത് രണ്ടുമല്ലേ ഇവിടെ 1 ഉള്ളത് അല്ലേ? അപ്പോൾ നമ്മൾ എന്തായിരിക്കും റൈറ്റ് ചെയ്യേണ്ടത്? 0, 1, 1. Okay, so 0, 0, 1. ഇവിടെ 1 ഇടണം. Then here also 1, 0. That means 1, 0. Okay, so what is Qn plus 1? അപ്പോൾ എന്തായിരിക്കും Qn plus 1 പറഞ്ഞേ? It is equal to Qn plus 1 is equal to what? നമുക്ക് ഗ്രൂപ്പ് ചെയ്യാൻ പറ്റുമോ ഇത്? ഇല്ല. അപ്പോൾ എന്തായിരിക്കും? First this is, we can select this. It is T bar, T bar, T bar, Qn. Okay, T bar, Qn. T bar, Qn. Okay, T bar, Qn plus this one. Okay, this is T, 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 here it is 0, that means it is T Qn bar. T Qn bar. Okay, so this is the characteristics equation corresponding to this T flip-flop. That is Qn plus 1 is equal to what? T bar Qn plus T Qn bar. Okay, so next we can draw the excitation table. Okay, so for drawing the excitation table, first column is Qn, Next column is Qn plus 1, and last column we had to provide the input, that is T. Okay, so this is the first, second, and third column of our excitation table. Okay, so we have to find the excitation table values. Okay, first we had to assign if both are 0, that means Qn and Qn plus 1 are 0. This situation, here situation, like 0, 0. Then what will be the value of T? It is 0. Okay, so that is 0. And next, assume that Qn is equal to 0 and Qn plus 1 is equal to 1. Qn 0 and Qn plus 1 on the situation, T value and that. What is the next value? But T value and that 0, 1. 0, 1 means this one. Okay. Okay. Correct. 1. Okay. 1. The next 1, 0. 1, 0. 1, 0. Okay. 1, 1, 0. 1, 0. What is the value of 1? Okay. 1, 0. It is also 1. Then last 1, 1. Okay. 1, 1. Qn and Qn plus 1 are 1, 1. Okay. So 0. Okay. Correct. 0. So this is the excitation table corresponding to this T flip-flop. Okay, so we have drawn a characteristics table. From that characteristics table, how find the characteristics equation. Okay, by using KMF, and also this is the truth table corresponding to this T flip-flop, and this is the excitation table. Okay, so this is all about the T flip-flop. Okay, so this is our T flip-flop, and this is a logic symbol. Okay, logic symbol is also there. Here only one input T. That is the only input in this T flip-flop. Okay, T, and the symbol is Q and Q. Sorry, output is Q and Q bar, and here we are giving the clock pulse. Okay, so this is the logic symbol corresponding to the T flip-flop. Okay, so this is the logic symbol corresponding to T flip-flop. So this is the characteristics table, this is the truth table, and this will be the excitation table. And this is the characteristics equation, that is T bar Qn plus T Qn bar. Okay, T bar Qn plus T Qn bar. Then for this you need to draw the this, waveform. Okay, so this is a waveform corresponding to this T flip-flop. Here you can see that we are assuming this is the clock symbols. ഇതൊക്കെയാണ് അതിന്റെ clock symbols. And this is the T input. Okay, initially the T input എന്ന് പറയുന്നത് 0 ആണ്. Okay, for the first clock pulse. Then assume that your current state is 0. Then next state is also എന്തായിരിക്കും 0 ആയിരിക്കും. Okay, then after a clock pulse, okay, here T input is 1. Then our next state എന്ന് പറയുന്നത് എന്തായിരിക്കും, that is also 1. It will goes to high for that clock period. In the next clock period it is 1. Okay, T input is also 1. Okay, then what will happen? It will toggle, like നേരെ ഓപ്പോസിറ്റിലോട്ട് വരും, 0 ആവും. Okay, then that will keep on going to the to next clock period. Here in the next clock period, the T is equal to 0. Okay, T is from high to low, so T is equal to 0. and the current state is also 0. So the next state is also, it will be equal to 0. Here t is equal to 0, current state is also 0. So next state is also, it will be 0. Okay. So here in this case, here t is 1. So t is 1, the current state is 0. In that case, the next state is 1. Okay. Here t is 1 and the current state is 1. The next state will become 0. Okay. So here t is 1 and the current state is 0. So next state is also 0. Sorry, t is here, it is 0. So current state is also 0. So next state is, it will be 0. So this is our T flip-flop. Okay, T flip-flop. This is the waveform of our D flip-flop. So this is all about the T flip-flop. Okay, T stands for toggle. Okay, so this is the logic circuit diagram, and this is a characteristics table. You can see this is the characteristics table, this is the truth table, and this is the characteristics equation. This will be the logic symbol and our excitation table corresponding to the T flip-flop. Okay, so that's all about the T flip-flop. ഇനി നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. അഭിനന്ദ്,
Present.
അഭിനവ്,
Present, sir.
അഭിരാം,
Present.
ആഗ്ന, അഖില,
Present, sir.
അചൽ,
Present, sir.
ആകർഷ്,
Present, sir.
ഗോകുൽ,
Present, sir.
അക്ഷര,
Present, sir.
ആൽബിൻ,
Present, sir.
അൻഷിത,
Present, sir.
അനുജിത്,
Present, sir.
അനുരാഗ്,
Present, sir.
അരുണിമ, അരുണിമ,
Present, sir.
ആഷ്ബിൻ,
Present, sir.
അശ്വന്ത്,
Present, sir.
അശ്വിൻ, അശ്വിൻ പവിത്രൻ,
Present, sir.
അശ്വൽ എം കെ,
Present, sir.
അശ്വൻ ടി കെ,
Present, sir.
അശ്വതി വി കെ, അതുൽ,
Present, sir.
Present, sir.
ദീപിക, ദേവിക,
Present, sir.
ഫാത്തിമ,
Present, sir.
മിസ്ബ, സഹല, ഷിബിലിയ, സുഹറ,
Present, sir.
ഗാഥ,
Present, sir.
ഗോപിക,
Present, sir.
ഇഷ,
Present, sir.
കിരൺ,
Present, sir.
മാളവിക,
Present, sir.
നബിൽ,
Present, sir.
മൊസീന,
Present, sir.
മുഹമ്മദ് മുഹസിൻ,
Present, sir.
ഫഹദ്,
Present, sir.
സദഫ്,
Present.
സഹൽ,
Present, sir.
നന്ദന,
Present, sir.
നേഹ,
Present, sir.
നിഹാരിക, നിർമ്മൽ,
Present, sir.
നിവേദിത, നൈനിക,
Present, sir.
പുണ്യ,
Present, sir.
രജത്,
Present, sir.
സഹില, സാരൻ,
Present, sir.
സാറ്,
Present, sir.
സഹല, ഷഹന ഷെറീൻ,
Present, sir.
ഷാനിൽ,
Present, sir.
ഷോണിൻ സെൽവരാജ്,
Present, sir.
സിദ്ധാർത്ഥ്,
Present, sir.
സിദ്ധാർത്ഥ് സുനിൽ,
Present, sir.
സൗരവ്,
Present, sir.
ശ്രീരജ്, ടൈഫൽ,
Present, sir.
വർഷനാഥ്,
Present, sir.
വിഘ്നേഷ്,
Present, sir.
വിശ്രുത്,
Present, sir.
പ്രണവ്,
Present, sir.
സെലിയ.
Present, sir.
ഓക്കെ, അപ്പോൾ നമുക്ക് അടുത്ത ക്ലാസ് കാണാം. താങ്ക് യു.